Welcome to this Geopandas tutorial video. I am Olagunju Nasiru, GIS analyst at GeoAfricana. In this video, I'll be taking you through the Geopandas library, and I hope this video is going to be one of many other videos in this Geopandas series. So if you find this video useful, kindly subscribe, give it a thumbs up so that I'll be motivated to create more videos like this. Okay, so in this video, our problem or the task at hand is very simple. We are going to be following this tutorial here. This website here, QGIS Tutorials, is owned by a man called Ujaval Ghandhi. He's a mentor, someone I that I look up to in the GIS industry. He wrote this website as a series of QGIS tutorials for beginners. Actually, it takes you from beginner to intermediate level in QGIS. It's a very good tutorial. It was very useful for me in my beginning days of QGIS, and I still reference it till today. Anyways, today we are not going to be working on QGIS, no. However, we are going to be using this tutorial to guide us in Pandas. We are going to be following his workflow in Geopandas. So this task here, which he has done with QGIS, we are going to be doing it in Geopandas, and the task is simple. The first step, we are going to download a shapefile. Then we are going to load that shapefile into our working environment, which is in this case Geopandas. As for him, he loaded it into QGIS, but we are going to load ours into Geopandas. So after loading it into Geopandas, we are going to filter or query it for places that are country capitals and also have a population of over 1 million people. Then finally, we are going to export our Geopandas or our GeoDataFrame as a GeoJSON file. So it's quite straightforward. Let's get started. So I'm going to fire up my working environment. This is my working environment here, and this is my notebook. And so I'll copy this address. I'll be using Anaconda. So in this tutorial, I'll assume you are familiar with Pandas, and I'll assume you are familiar with Anaconda. If you are not familiar with Pandas, then I'll advise you to take one of many tutorials that are available for free or paid online. One of those paid platforms that I'll recommend a lot is Ustaki. This video is not sponsored by Ustaki, so but I'm just recommending them because I've taken their course and I found value for my money and my time that I spent. So I'll advise you to also take their course if you are new to Pandas, Python, NumPy, SQL, and even Jupyter Notebook. Good. So I think that's it. I can close this tab. If you want to learn more about Geopandas, you can go to the official documentation here. And finally, yes, since this is my channel, I have to talk about myself more. So as I mentioned earlier, I'm Olagunju Nasiru. I'm the founder of GeoAfricana, and I'm the principal consultant there. So if you have any GIS projects you need assistance with, you need an expert on, then you can contact me. You can learn about us, more about us here, and you can fill in the contact form here, and you can be assured that I'll get back to you within 24 hours. Okay, so that's it. I can close this tab. You can connect with me on LinkedIn also. Good. Now the data is available that I'll be working with is available on this website here, but we will not be downloading it. We will not download it from here. What we'll do is this. Here Ujaval Ghandhi has done a great as is our task for us. So what he did is this. He downloaded the file and he hosted it on his server. So instead of going to the Natural Earth website to look for the download link, he has given us a very simple download link here to get the file, so we can focus more on solving the problem. I'll make the link available in the description. So that said, let's get started. Now my Anaconda shell is running, so I'll cd into my working directory, which is this folder here, and enter. Then I'm going to activate my environments. So conda activates. I have an environment called GeoData and I'm going to activate it. I've installed a lot of libraries that I'll be making use of in my data science and geodata science projects. So enter. Now the library is the environment is activated, as you can see here. Then the next thing to do is to fire up Jupyter Lab. So to fire up Jupyter Lab, I have to just type Jupyter Lab, enter. It will take a few seconds to come up. Let's wait patiently. So while that is loading, okay, good. Okay. Right. Great. So why I like Jupyter Lab is this. Whenever you download any file or you create any file in your notebook, you can always see it here. So, and also you can always copy the path or the name of any file and paste it into your notebook. Now I'm going to clear all outputs so that we can start afresh. Restart kernel and clear all outputs. Yes, I want to do that. Okay, that is done. So we can start from the beginning. The first thing we are going to do is to import Geopandas as GPD. Pandas is imported as PD. Geopandas is imported as GPD. So that's the convention. Enter. It's taking a few seconds to type to import. I believe that's because I just put on my system. Then the next thing we are going to do is we are going to import this request module from the URL lib library. So it allows us to download files from the internet or access websites from web pages from Python, from within Python. So shift and enter. That has been done. Then the next thing is to download our file. The address of the file is here as a string stored in this variable. Then the name I want to give the file when it is downloaded is available as a string and stored in this variable. So I pass these two variables into this URL retrieve function and it's going to download the file for me. To take a few seconds. It's done. You can refresh. Now you see the file pop underscore places. Then the next thing to do is to extract this file because it's a zip folder. If you check, it's a zip folder. So you have to extract the content. Obviously you can right click and extract, but I'll do that with Python. So from zip, I'll be using this zip file library. The file I want to extract, this is it. Stored it into a variable. Then with zip file, extract this and extract it in a read-only format. So I'm not writing to it. So just extract, and I believe it has extracted. Can refresh. Good. So we have a bunch of files, and that is the bane of GIS analysts. Shapefile is very messy, but it's easy to share. There's so many software and libraries can open it, so it's the most common format for sharing GIS data or geographic data. The most important is this .shp. So we are going to copy the name and the including the extension, Ctrl C, and we'll ask Geopandas to read it. That said, it is important for all the other formats too to be available, all the other extensions. You can see they all have the same name but different extensions, and each of these extensions has its own use. So if you delete one of them, then your file might not work correctly or might not work at all. So I've copied the name of the file, including the extension, the SHP extension here. Then I'm using the read underscore file method in Geopandas to read it. And Geopandas reads a file into something called a GeoDataFrame. You know, Pandas reads into a data frame, but Geopandas reads into a GeoDataFrame. So the good thing about Geopandas is that you have just one method or one function to read any type of GIS file format. You have a shapefile, you have KML, you have GeoJSON, you have GeoPackage. Just use read underscore file. Although the arguments they will take might be a bit different from one another. Unlike in Pandas where you have read underscore CSV, read underscore XLS, read underscore HTML, depending on the format your file is coming from. So I think this is a bit handy. Enter. So we have our GeoDataFrame, and like in Pandas we can read it. So we can inspect it using the .head to view the first few rows. So by default the .head function returns method returns just the first 5 rows. So we can, but I need just the first 3 for now. We have 39 columns and 3 rows that were returned because I specified 3 rows, and you can see all the columns. There are so many of them, but the most important for now is this geometry column. This geometry column is what makes a GeoDataFrame different from a data frame. So this is what Geopandas will read to treat your file, your data frame as a GeoDataFrame. This contains the geometry and also the CRS of your file. Like in Pandas, you can inspect it to see the list of all the columns that are available. So you can just length, right? You can check the length of all the columns that are there. You have 39 columns, as was even mentioned at the top here. We have 39 columns here. Okay, so we have the list of all the columns. For this project, we are just going to be concerned about 3 columns. This add mockup column, which states whether a place is a capital or not. So places that have capital, let's see if we can find it here. It is listed here. Add mockup. Oh no, it's not here. Okay, good. We have add mockup here. I'm saying it's not here because Pandas has truncated the columns, so it's not all the columns that are listed. So add mockup you have 0.000. So the values there are 0 and 1. We can check that, right, by GDF add more, add 0 cap dot unique. Sorry. So you see we have 0 and 1. So 0 means that it is not a country capital. 1 means that, oh, that city is a country capital. I didn't mention before, each row represents a city that has very high population across the world, in each of the countries in the world. So we are going to filter for which cities are country capital and also have a population of over 1 million people. So we said we are going to be working, this column is the one that contains whether it is a country capital or not. Then this column contains the population. So pop underscore max contains the population. Then next, one of the things that are more specific to a geodata frame, unlike a normal pandas data frame, is a geodata frame has something called the CRS. CRS is a complex topic, but basically it just represents, it determines how the geometry is drawn, because the earth is a globe and now we are drawing it onto a flat surface. So there are different ways of redrawing it, so to speak. So, well, it's called projection. So the act of redrawing from a 3D surface to a flat surface is called projection in mathematics. So in geography, the art of drawing the spherical earth onto a flat surface is called projection. And there are many projections, and one of these projections are what we call the CRS. But there's more to CRS than projections. The way you draw it is called the projection is part of the CRS, and there are other things that come into the CRS, like the datum also. Anyways, here we can view the CRS, the way this geodata frame is drawn on a flat surface. So shift enter, we can see that the format is EPSG 4326. This is important. It's important to inspect the CRS, because when you're working with multiple files, the CRS, it's good to unify their CRS, bring them into a common, convert them into a common CRS, as we are going to let's quickly talk about that now. So you can use in Geopandas, there's the geodata frame has a method called to underscore CRS for converting to another, from a CRS to another CRS. So let's say I want to convert to another CRS. So let me just search for a, okay, good. So this is a CRS EPSG 26393, which is the CRS that Nigeria use, the eastern belt of Nigeria. But for the western belt, which is the parts of Nigeria that I can copy this, and now I can reproject this into that new CRS. Just paste this here and shift enter. Now it's returning a new GeoData frame, which I can store into. So it's not modifying the existing GeoData frame. It's only to convert it. It will convert the CRS and create a new GeoData frame. I hope you get that. So we can call this new underscore GDF. Good. So enter. So now we can check if the original GDF, the CRS, is equal to the GDF of our new CRS of our new geodata frame, and we get false. So we can even check the CRS of each of them individually. Good. So we have a tuple. This is messy. Let me just, so shift enter. This one, okay, good. The CRS of the, let's do it this way. Good. So the original geodata frame, this is the CRS 4326, and the new geodata frame has this CRS 26391. If you are going to be working within Nigeria, then a CRS like this is good for you. It's using the UTM, and the unit of measurement is in meters, as we can see. So, but this one uses a geographic unit of measurement, so it's not fit when you're measuring. This 4326 is not a good CRS for measuring distances and areas and geometry shapes or metrics, because it will give you very wrong answers. Next, we can quickly visualize it on the map using the dot plot method, GDF dot plot. So just at the top here, we inspected the attributes using the GDF dot head, which is available in pandas, but here we are inspecting the geography, the distribution. We can see it on the map. So this represents the bound of the world boundary, and the points are plotted within it. So you can see that roughly there are so many points in Africa, North America. You can see that there are so many points. To see the number of points, we can simply just get the shape, GDF.shape, enter. So you see that there are 7,343 rows and 39 columns. So in geographic terms, we can say there are 7,343 features and 39 attributes are stored for each of the features. But it's 38 attributes. Remember that the geometry is the 9th column, and we don't call geometry an attribute. Okay. As you might have noticed that this is a, if you are used to a GIS software like the GUI, this kind of map is not really your type. You are used to an interactive map where you can zoom in, zoom out, inspect points. But here you can't click, it's a static image. So Pandas has a library, has a functionality that allows you to use .explore method to view your map on an interactive map. So the .explore method takes a number of parameters, keyword arguments. The first is the tiles, which represents the base map that you want to make use of. By default, I think it uses the OpenStreetMap as the base map. So let's just but in this place, in this case, we are going to be using a custom base map. So if you don't specify this tiles argument here, this tiles parameter or argument, whatever it is, if you don't specify it, then it's going to use OpenStreetMap by default. But here I'm using Google base map. So you might be wondering where I got this URL from. I just Google. You can just go to leaflets base maps. Okay, let's start for that. So here we can see a list of so many base maps. There are so many base maps here. So this, and here this address here represents the base map. You understand? This is the URL for this base map. So you can just copy this and use that. Also, Atari Labs has this tutorial for how to add base maps in QGIS. There are so many. So how to add Google satellite base maps in QGIS. So you can just copy any of these addresses and use. If you want their road map, you want the terrain map, you want the altered road map, then you can get the addresses from here. Finally, in one of my videos about um, adding base maps in QGIS, I showed you a script. Can I find that script now? I can't find it now. Okay. Okay. I can't find the script now. So I showed you a script on, I believe this is the script. Yeah. No, it's not. This is another script entirely. So I can't find the script now. I'm very sorry. But I showed you a script that's a Python script that contains um, so many addresses to base maps, very many of them. So you can just copy one of them. Let me try to look for that. Anyways, I'll provide a link in the description. I think that is going to be better and faster. I'll provide a link to that in the description. So if you are using a custom base map, you must use this attribute method. Then keywords, any other keywords, marker keywords is one of the arguments you have to that are optional. So here I'm just stating it takes a dictionary of many key value pairs, setting the radius, which is the size of the marker, to 10 to make it bigger, because these points are very small, which is the default. I want it to be bigger because on an interactive map you might need to click on points. Then I'm setting the fill color to red. Then when a point is clicked on the map, I want just 3 attributes to be available for me: the name of the city, and whether it is an administrative capital or not, and the population of the city. So shift and enter. Before it loads, I'm only I'm plotting only just 100 places. So because if I try to plot the whole GeoDataFrame, it might be very clumsy and take a lot of time. So we are just exploring quickly. So here we have all the cities. So you can see it's interactive. You see different things. You can zoom in on any city, or just zoom in on this part of Africa in Togo. You can click on it. So when you click, you see its name. Sotoboa is the name of the city, and the admo cap is 0, and the population is 21,000 people. Obviously this is going to be filtered out later, because we said we are going to filter for country capitals that have a population of over 1 million. So in the first place, this is not a country capital, Bassa, and also the population is just 61,000 or 62,000 roughly. So this place is going to be filtered out. We will not see it in our results. Next, now that we have explored our data and we are familiar with it, the next step is to filter it. So as we said, we are going to filter for places that are administrative capitals and also have a population of over 1 million. So for the first condition, that has a population of over 1 million, we are creating a mask. A mask is just a Boolean Boolean series in pandas. So we can just copy this. You can inspect it. That's the good thing about using a notebook. So if you are in doubt about what anything returns, Ctrl V and test it out. Oh, we have to return it. So mask 1 and C. So you see false, 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 true, true, true. So now all the places that are false, all the rows that are false are where this condition is not satisfied. If we use that to filter into our GeoDataFrame, it will return just the rows that satisfy these conditions where there is true. So that is a common paradigm in working with pandas. And so, as I said in the beginning, I will assume you are familiar with pandas, so I won't go much into that. Then we are creating a second mask here, which is filtering for where it is an administrative capital. So that is where the admin 0 cap is 1. that means it is a country capital. Then we are filtering our GeoDataFrame using these two conditions. Mask 1 and mask 2. So where these two conditions are both satisfied. If you want to say one where either of the two is satisfied, we use this pipe symbol. But here we want to filter for where both have to be satisfied. So, and good. So now we can check our GeoDataFrame, the result, sorry. We have stored the result of that into this variable, and we can check the results, how many places meet are filtered. So it means we have 103 state capitals in the world that have over a population of 1 million. That is the meaning of this. But before we go, I want to quickly say something here. There's another method you can use here. Here I broke it down into, I first wrote the first mask, then the second mask, and use them here. This is more readable and easier to understand, especially for beginners. But this is neater, more concise. So I just use the two conditions in one line. But notice that here I have this first condition in brackets, and I have the second condition in brackets. So when you are having two masks in one line, you have to put each condition in brackets, or else it won't work. Okay, so I can comment this out. You can use whichever of the two conditions you find more comfortable. Now that we are filtered, the next thing to do is to explore the results. So GDF filtered, we are exploring it. I can try another base map. Let's try another base map out, and this time I'll be using the hybrid. Let me use the terrain, Google terrain base map. Control C, then I'll paste that here. Control V, then let me just change this to Google terrain, then enter and wait for it to load. Good. So now we have this here, and you can click on any city. I'm sure the capital of Nigeria will be there. So Abuja, this cap in official, and I don't know what this column means. So let me just okay, what I've done here is the columns that I specified should be available when I click on this pop-up. I specified this cap in, but this cap in doesn't have much meaning. So let me change this to what we have here, admin 0 cap, so which states whether it is a capital or not. In fact, since it's already a capital, we don't even need it. We know that there are only capitals available here, so just need the name and the population. I think that is better. Enter, then click on Abuja. Good. So we have Abuja, and population is 1.6 million people. Okay, then the next condition is to export. But before we export, there are so many columns in our data, 39 columns, 38 attributes. I said is 39 minus 1, because 39 includes the geometry, so we are not counting that as an attribute. So we want to reduce it, we want to make it cleaner, to just our output file, we want it to just contain just two columns, the name and also the population of the place. So the name of the place and just the population. Now I'm specifying this geometry column, because if I don't add this geometry column into the output, what I'll get is just a GeoDataFrame. If you filter now, you filter for the GDF. So what you are doing is the GDF filtered, which is the output that we got after filtering our GeoDataFrame, and we are extracting just these two columns and also the geometry column, then storing that into the original variable again, GDF filtered. And now we are going to have a new GeoDataFrame. Sorry, not a new, because it's a view of the original, not a copy. Now, this is the wrong way to filter in Geopandas. If you filter this way without including the geometry, then you are going to get a normal pandas data frame. So we can try that. Type of GDF. Let me just copy that. I'm feeling lazy to type. Okay. Control C, Control V. So we can check the type of each. This one that we included the geometry column, and this that we didn't include the geometry column. So Shift Enter, Shift Enter. We can see that the first one is a GeoData frame. The second one is just a normal data frame in pandas. So it's a pandas, this one. So you must include the geometry column or else it won't work. Finally, we are exporting. Our file is ready to be exported. So we are exporting and we are using the dot to file method in pandas, in Geopandas, to export our file. So it takes a number of arguments, but the most important ones are the name of the file, the name you want to give the new file you're exporting to, and it must include the correct extension. Also the driver. So the driver you are going to specify depends on the format. You can visit the Geopandas. You can Google Geopandas to file. So you can see that here we have the different drivers. So okay, it said if you want to see the drivers, you can just import Fiona and click on and check Fiona.supported drivers. So let's try that out. Let's import Fiona. Good. Then let's check Fiona.supported drivers. So you can see depending on the format you want to work with. So since we are working on GeoJSON, this is the driver for GeoJSON. So we want to export to CSV, open file, GDB, Esri JSON, then the Esri shapefile, which is the default. So if you don't specify any driver, it's going to default to export your file to a Esri shapefile. Okay. So now we can export, Shift and Enter. We are getting this warning which we are going to ignore. You can safely ignore it. I've checked it on Stack Overflow and said it's safe to ignore it. Then also, so now the file is available in our working environment. Let me search, populated capitals. This is it, I believe. Yes, populated capitals .geojson, 17.5 kilobytes. We can check in our folder, and also, yeah, we have it. Yeah. So just to confirm, if our file is was exported correctly, no errors, we just explore it in using. We are going to use the explore method to quickly view it. So we are reading the file, populated places.geojson, and we are exploring it. So here we have all the points. So that's it for this video. I hope you found it useful. If you did, please subscribe, give it a thumbs up. I'll be making more videos about that hopefully in the nearest future. So thank you for watching, and I'll see you in another video. Bye for now.